So it's my pleasure, as it will be throughout the event, to introduce the next session. And so I'm pleased to introduce our second session moderator, Jess Watts, who is Marco's Ocean Planning Program Manager. Jess oversees a diverse portfolio of regional ocean planning initiatives. They are the staff lead on Marco's Mid-Atlantic Ocean Planning Committee, the Marine Debris Work Group, whoop whoop, the Ocean Conservation Work Group, Maritime Commerce and Navigation Safety Work Group, and the Coastal Hazards and Resilience Initiative. They also chopped off a bunch of their bio that is much more extensive than this and would not allow me to read that. So I encourage you to look into that, ask them plenty of questions. Without further ado, I invite Jess up onto the stage. Thank you.
Okay, thank you, Will. I do want to acknowledge, I know a lot of you aren't used to seeing me up here on the stage. I like to stay at the back of the room. But I want to acknowledge that this session was originally meant to be moderated by Katie Morgan, the Mid-Atlantic Regional Coordinator for NOAA's Marine Debris Program, and our very own federal co-lead for the Marco Marine Debris Work Group. So Katie did all of the great work to shape and design this session, and I'm just honored to fill in for her today. Let's see. I remembered. So before I get started, I do want to take a moment to acknowledge our colleagues and partners from federal agencies who are unable to make it here today because of the lapse in appropriations and ongoing furloughs. Their work and collaboration, they're an essential part of this community, and their presence is truly, their absence is truly felt today. And we very much look forward to their return and continuing our shared efforts together. So like much of our work at Marco, we're constantly trying to balance what we learn from science, especially on issues like microplastics, with the policy and management questions that follow. And the goal here is to keep science and management in close conversation together so that we can move forward collectively to address this global issue. And so over the next hour, we'll explore how emerging microplastics research connects with those real-world policy and management needs. So I'd like to first introduce to the podium Dr. Beizhan. Dr. Yan is a Lamont research professor at the Lamont Doherty Earth Observatory of Columbia University and a co-director of the MS in Sustainability Science program at the School of Professional Studies. He earned his PhD in 2004 from Rensselaer Polytechnic Institute in Troy, New York. I hope I pronounced that properly. Since joining Columbia in 2007, he has built the Environmental Organic Geochemistry Lab from the ground up. Dr. Yan leads collaborative research on measuring microplastics and nanoplastics in New York waterways and air, investigating their links to adverse health outcomes, including neurodegenerative diseases, and developing engineering solutions to mitigate plastic pollution. So in his presentation, he'll share how he coordinates plastics research at Columbia and works to bridge research with those management and regulations. Dr. Yan, I invite you to the podium.
Good morning, everyone. So yeah, I'm sorry that the Katie cannot be here. The reason, I was actually got a lot of help from her as well, because we, about 3 or 4 years ago, and when we're looking for opportunities, and she's always the first person to giving us, say, hey, there was a NOAA program is running, you probably can consider to apply. So through her encouragement, I was actually being able to got the funding from NOAA for twice, and with about total about $6 million for doing the research on especially the first one is the talk I'm going to talk about today for microfibers using the laundry filters to remove the microfibers. The second one, we're actually using the AI-assisted, machine learning, technology to identifying plastic items like microplastics in the rivers and also in the coastal areas, and then collecting them. So this is the systems we are developing as well. So thanks to Katie, her encouragement, and certain I would like to see her in the future. But Jess, thank you very much for your invitation and also your introduction. So, okay, so let's talk about first is what, I'm, as I mentioned, I'm also the, working at the Columbia for a couple of, places. One is this one is called Lamont Doherty, because I'm doing, Lamont Doherty is basically a geoscience institute and doing a lot of research. For example, there was one major geoscience theory, which is called planic tectonic, and this is the place that was found in 1960s. We are the place that confirmed that's a planic tectonic. And also we do a lot of other research. For example, the global warming, this term even coined by our researchers at Columbia at the Lamont Doherty. So we did quite a lot of work on the Beizhan as well. So I'm also doing research, doing the teaching at as mentioned that I also do the co-director of math programming in sustainable science and also teach course at environmental science policy. So that's a reason that I'm actually right now have many research areas. One is, as I mentioned, I'm a Lamont Doherty, so I'm doing the research on the environmental behaviors and also distributions of microplastics in the New York City. But also goes to the two pole regions like Antarctica, snow, and also we also find out the microplastic deep in the sediments in the oceans. We also even goes into the desert, like remote desert, like Sahara Desert. We actually identify microplastic and nanoplastic in those areas. The second part I'm doing research is actually I'm also collaborating a lot with the researchers from the health, like environmental health, so that I doing the research, basically characterizing exposure and the linked exposure to the health through the collaboration with the Mailman School of Public Health at Columbia, Rutgers, and also NYU, Harvard, etc. So we're doing a lot of neurodegeneration, development, disease associated with micro and nanoplastic, exposure. The third one is recently I was collaborating with, our engineering school at Columbia to developing these engineer real-world solutions. For example, the microfibers removal, and also the AI-assisted, plastic collection. And because I'm teaching course at the sustainable science and also environmental science policy, so now my students always ask question, how can your research link to the policy? So that's why I started the first area, which is about 2 years ago, really new, is to promoting the political regulations, and then basically is collaborating with the, policymakers, nonprofit organizations to do the research, and helping them, providing the evidence on that. So that's my 4 areas, okay? Did I speak too much? So the one reason is that we are facing one of the most significant pollution issues in human history. And from this plot, you can see the plastic production was exponentially increased since 1950. And there was this exponential increase was not stopped. The reason is because the electro, vehicles that right now they're more into the, rather than use the gasoline, but they're using the electricity. And so the gasoline companies try to find out the secondary alternative method to market it for their petroleum. This is their market. And so among this, there was about probably right now about 10 billion of metric tons of plastic being produced, still 1/3 in usage, but about 80% being recycled very pathetically. Majority of them will be discarded in the environments. When they're discarded in environments, they cause ecosystems. That a lot of the news about the intestine of the sea turtles, etc. And so, but also they are under, physical, chemical, and biological weathering. So when they become smaller and smaller, when they reach to the 5 millimeters, we call them microplastics. When they reach to the 1 microns, we call nanoplastics. So the reason I'm saying that we are doing the research of the health, so we know the microplastic if it's large would not be able to get into the body. Only the small particles, for example, in a particle size less than 10 microns, can really go deep into our lung, and they maybe cross the air and the blood barrier, get into the blood, and then being transferred to the vital organs. So we are really looking into, if you really look into the health effects, you definitely need to go to nanoscale. And about 4 years ago, there was no method of basically identifying those small particles. And so it's quite disappointing because at the time we were using the SEM, TM, all sorts of methods, and we could not be really identify any method that being able to identify them. So that I started to doing the research, especially looking into the reference and looking into where we can find those, find this method, and eventually we find out this method called stimulus Raman scattering. And this method can increase the sensitivity about like 1 million times. And we use that actually being able to identify nanoplastics down to like 16 nanometers. And so we actually use the bottled water as the first, case studies. Because we know if the person get exposed from the micro and nanoparticle because of bottled water, then definitely you are exposed because that was all over the place. And we know the bottled water is supposed to be the most cleanest water, right? So that's why we're starting with that, and it turns out we find out about like 240,000 nanoparticles and microparticles in just 1 liter bottled water, which is about like 100 times higher than the previous report. So then, we look into that, and then we actually, right now, we actually not only doing the, bottled water, but we're also looking into tap water. We're also looking into the cerebrospinal fluid in the brain, like a brain fluid. And we find about like 1,000 times higher of the micro nanoparticle in our brain. So clearly, it's in our body. Clearly, it's getting everywhere. So, today I'm coming here not to try to scare everyone. I'm coming here just to see, how we can solve the problem, right? I don't want to give it, for example, I have a result for the New York City. I know it's 20 times higher in New York City tap water, but I don't want to provide it without solutions. So that's why we are developing method for remove the micro nanoparticles from the bottled water, from drink, from the, maybe some other things like a cerebrospinal fluid. And so this is the kind of things we are doing right now. But another thing that we are actually doing is also fitting into this conference here is that we also developing the filters, laundry filters that can remove the microfibers from the laundry washing machine. And we know that it was about microfibers, especially in the ocean waters, about like 1/3 of the microplastic coming from textile, which is the single largest source for the oceans. And so we want to remove them at the space. The part reason is because when the washing machine, when they're generating billions of particles, that goes into the sewer system sometimes. But the sewer system was not really designed to remove microplastics. So they are basically 10% goes in effluent, 90% go to laundry, goes to the sludge. And then the sludge was being applied for the fertilizers for the farmers. And so they are re-entering into the environment. And the runoff takes out and then goes get into there. So that's why we get a lot of the, getting from. So our method is try to remove them first at the source, rather than go to sewage. Because in the sewage, there was many other things, like particles, all sorts of other, like contaminants. We don't want to be there because then you can, very difficult to reuse it. So our hope is that we can collect them at the source and also we can reuse them. So basically loop solution for that. So that's why, target of our new system can be self-cleaning, can regenerate capacity, requires low maintenance because you don't want the people operating the instruments machine, like a washing machine to replace the filter and then clean your filter for every 2 washes, right? That compliance will be very low because no one have time and it's not also a pleasant work. So what we try to do is could we accumulate the systems for like a half year and then dump the filters, dump these things a half year, right? So then that's not a big burden. And also we want to also last for years. You don't want like $200 of device only used for 2 years. And so we wanted the system that can last for at least the same year as the washing machines. And also we want the filter down to the nanoscales. As I mentioned, we know nanoscales, nanoplastic is a dominant health issues. We want to do that. So we want to also remove that. And also we also need the system have a high flow rate to preventing any wastewater being holding back. Because if you're holding back the wastewater from the washing machines, then you potentially recontaminate your clothes. So we don't want that. So we actually looking into all the market. We could not find any commercial products that can fit into these categories. And so we actually have to developing our own. So this is just to give you a test that what kind of particle we are encountered. You can see there was a lot of these small small particles that was about like a 20, you can see that about like 100 microns, and they are in the, this is from the gray water, basically the washing machine, from the wastewater. You can see there was many, these small tiny particles. And so we actually, the second generations, which is in the right plot in your side, and so you can see the second generations, it's really big. The reason we want creating this one is try to test whether this prototype can work or not. So we actually over capacited it. So so we actually use this over capacity was about 20 times. For example, this clearly showing in the left side of your side, it was basically the flow rate. And the flow rate is about like 1 gallon per second. And so which means 60 to 70 gallons per minute. And your household washing machine typically 4 gallons per minute. So we're about like 15 to 20 times in terms of the over capacity. But also to see this, whether that's actually being efficient. So the right plot showing you the two basically comparison. One is laundry gray water, which is without filtered. This is the orange color. And then the blue color was actually showing the filter. And you can see that the filter, which is 100 microns per size, not only takes out any particles more than 100 microns, but also takes out any particle more than 50 microns. The reason, as I mentioned, is the particles we are seeing is very fluffy. So even you just see that 50, but actually, because they are fluffy, they actually can be more than that if you think about the particle size. So this is basically what we are doing. However, what we are even going to do is just to see, let me see, okay, just to see where the future. Okay, so what I'm trying to do is not only doing 100 microns, because as I mentioned, we need to see much lower pore size. So we actually have 10 microns pore size filter. We also have 0.5 microns, 0.5 filters. So we can test that. And then basically is try to providing the scientific evidence to showing to the policymakers that which one is the best. And also we want to test out whether the toxicity associated with particles. So what we try to do is separating the particles based on their particle size, and then use a fish to figure out the toxicity associated with different particle size. And then we can say, okay, this 10 microns or 0.5 microns, let's say, which one is more toxicant? Should we go with which one? So that's kind of things we are doing in the future. So, but I'm coming here also think about how we actually coming together, not just by myself. I'm just a poor scientist and environment geoscientist. So we cannot doing too much without help from others. That's why I extended for the collaboration. So that's why I set up this called a PPAS, which is the Columbia Plastic Pollution Analysis and Sustainable Solution Network. And through this network, I reached to about 3 years ago, about 40 faculties at Columbia University. We have the faculty from the law schools, we have faculty from the economics, we have faculty from the engineering school, we also have from public health. And so we basically, because Columbia is a very comprehensive university, so we basically reach out whatever the professors that are interested in this project, working together. So we have these 3 years, and right now that we, based on that, we increase member number goes to 66, majority of the faculties. And so we organize webinars and basically introducing the plastic treaty. I'm going to talk about a little bit later. And then we also talk about developing a new course, which is I opened, and have a lot of students apply, select that course called Plastic Pollution and Sustainable Solution, basically educating our next generations of the researchers. We have about a lot of the program Columbia have a lot of program related to, sustainability and environment. We have about 1,000 students almost in this area. So we really try to open the course and educating our next generations. And so we also, of course, this professor need to find the source, so we actually successfully putting into the efforts into the writing the proposal together. We got funding from NOAA, got in the NIEHS, National Institute of Environmental Health, and also the other money as well. So basically what we try to do is actually, when we look into this network, we did get a lot of achievement. However, we're still thinking this is not good enough. We should forming a cross-campus center that really targeting for these, issues. For example, we want to know not only just downstream, we want to go to upstream. For example, we want our researchers to be able to influence the polymer designs so that we know the toxicity. We are not going to use the high toxic materials to be at the first stages. Because this everything we are trying catching up. But how we can prevent them to be problem at the starting of designs. So this is actually our research. We are trying to collaborating with a mailman toxicologist to really influence the designs, okay? And so this is we try to cross, getting a center called Center for Polymers across life cycle, not only just for our, just the downstream side. So we also get a strong support from Columbia Climate School. And so because we are part of the Columbia School, so they're giving us about $250,000 to basically promoting two things. One is that is policies. Because we know, just by ourselves is not enough. So Columbia is giving us money so that we can, link with, stakeholders, not only us, but also nonprofit organizations, and also the, senators and et cetera, to promoting the fibers, because we know, there was one a bill that have being bring into the Senate floor, which is called Fighting the Fibers, Microfibers 2024. However, they're used to 100 microns as their screen sizes. And so what we try to do is not only putting that one as putting that one, but also asking them to decrease the particle sizes, the pore size of the filter, so that we can remove the nanoparticle even from the stage. So that's one of the things we are doing. And also the second thing is also we already have this kind of development of the techniques. We really want to commercialize it so that we can really to helping the society. So, and another thing we are doing is also we are not only contacted the, doing our research, but also reaching out to the policymakers. So we, our research being used for the, congressional hearing, but also being in the international, like a political treaty, conferences. So what do we try to do is not only, affecting the local, but also affecting the internationally. And because without the political treaty be signed, no matter how effort you were putting in, there was not going to be changed too much until you really have a binding solutions for that, right? So that's the reason right now we're actually working together with my students, because as I mentioned, in Columbia, we have about 4,000 of the graduate who's working in this field, in the climate, in the, environmental. So we also have many students working in the United Nations. So we try to helping them, to try to asking them to go with us. One of the issues of the United Nations of the political treaty negotiation being stopped because of we call eight-minded countries. And these eight-minded countries are majority of the producers from the petroleum, for example, Saudi Arabia, and also the Iran, and also the another country is called Kazakhstan. For example, Kazakhstan there was about 25% of their GDPs from the plastic and also petroleum. So if you try to sign that one, then we're really cutting down their GDP. So that's they're unwilling to really sign the contract. So that's why right now we are talking with Kazakhstan government and try to using Columbia Sustainable Solution, a sustainable network to finding a sustainable solution for them, so that they basically remove this sticking point, so that we can sign this global treaty programs. So that's the kind of the working we are doing right now. And not only just to focus on the United States, but also we will try to figure out how way to solve this problem by the on Earth, not just by ourselves. So we also call putting. I don't think I have time, right? Okay. So currently the one way we think about it is, okay, let's say United States eventually will passing this law, regulation to really remove it. How we can evaluating the efficiency of the law? So that's a critical question, right? How do you quantify them, whether the impact of that? So we basically have tried to set up this called policy toolkit. So we do two things. One is we do the mapping. We know there was a lot of mapping, policy mapping, where the state, national, and also international. However, the problem is that when there was a program money, they are set up the policy mapping. However, when the money goes away, then the map will never been updated. So what we try to do is actually we are using the students from the data science, big data science, using the machine learning techniques to automatically to downloading and identifying these new policies and downloading into the map. Basically, this map will be updated all the time. So that's kind of the things we are doing to see whether we can have. And the second thing is also, we know we have the carbon footprint. Like everyone knows the carbon footprint because the total mass of the carbon, right, CO2. So, but we never have set up the plastic the footprint very precisely. So because the plastic has two issues. One is the mass, but also is how long they are being degrading from the plastic to the other materials. So we're actually creating this called plastic impact index. And so we basically using further index, around the activity and the manufacturer so that we can evaluating each company's their footprint of the plastics in the town, the state, and also nationally and internationally. So that's why we want to set up this footprint. So helping quantify what actually being impact. So I think I have time, but this is basically what we are doing this summer. We have very talented students who set up this called post-disposal impact index we already established, and then put it into the different scenario, landfills, oceans, and recycling, reuse, and incinerations, different scenarios, and we have this set up. So in the future, probably in the next 1 year, we're going to set up the other index, and then we combine, aggregating them together so that we be able to really evaluate them. So another thing is that I mentioned that we, Columbia was try to not only just the policy, but also try to including how we can actually making, these things. When you have a pattern, could you also commercialize that? So my students, who's, Yanni, he's working in my lab, and then he knows our technologies. He forming this company, and so we call it Mobi. And right now he's, he got 400 million, sorry, not 400 million, 400,000. 400 million would be great. 400,000 of the money to invest money to really start this company and to do the help with that. I think with that, this is my, I'm sorry, I a little bit over, yes. Okay. I think we can wait until the last minute. Okay, thank you.
Thank you, Dr. Yan. I love it when we can see the the importance of an interdisciplinary approach to issues. I know our work group has been asking and discussing a lot of the things that you talked about, and so I expect that there'll be plenty of interest and discussion when we get to that later. So next I'd like to introduce Paige Hobaugh to the podium. Paige works as an environmental scientist on submerged aquatic vegetation, on plastic pollution, and on water quality projects at Tetra Tech. Paige will walk us through the background, content, and applications of a microplastics monitoring framework developed by Tetra Tech for the Chesapeake Bay program. Paige.
Okay. Hi, everyone. My name is Paige Hobaugh. I am an environmental scientist at Tetra Tech, which is an engineering firm. Our office is in Owings Mills, Maryland. My supervisor is Bob Murphy. He was unable to make it today, so I'm speaking in his place. Hopefully, I do it justice. But unfortunately, you will be getting fewer fun anecdotes. So today I'll be talking about the framework for monitoring plastic pollution in Chesapeake Bay that we were charged with developing for the Chesapeake Bay program's Plastic Pollution Action Team, otherwise known as PPAT. That's what I'll probably be calling it from here on out. And this is part of a larger plan in getting better microplastic monitoring at the Chesapeake Bay program within the watershed, which is huge and a very interesting undertaking that they're taking very seriously, and it's been awesome to work on so far. So I'm going to talk a little bit about the roadmap it took to get to this point. So the process began before 2019. Like the last presentation showed, microplastics are ubiquitous, and there have been one-off studies throughout, I want to say, the early 2000s and late 2010s showing that there are a lot of microplastics in the Chesapeake Bay. None of that was done on a scale with which you can verify temporal or spatial trends, so it's really not enough to make policy decisions or management decisions with. And that's what we were talking about at the State of the Science workshop in 2019. And after that workshop and the report that came out of it, the Chesapeake Bay program leadership decided that, hey, we don't have enough information. This is a large enough and important enough problem. It affects enough of our goals and outcomes that we need to pay better attention to this. So they charged Bay program staff with creating the Plastic Pollution Action Team. And then PPAC got to work right away. As you can see, we started off with an ecological risk assessment on juvenile striped bass, which is an important recreation fish in the watershed. We put together this document, and then there's already off the bat been some source tracking studies going on. But you can kind of see how it's been going. And this is where we're at today. This is we did this in 2024. I think it took a year to complete, if not a little bit longer. Microplastic monitoring strategy. It took a lot of research, literature reviews, and a lot of talking back and forth, lots of communication with the Bay program, with the experts who know what kind of monitoring programs are in place and how they work and where they exist. Okay, on the left, we have the microplastic monitoring strategy. That's what the document looks like. I have a QR code at the very end you can scan that will bring you to the document if you're so interested. And on the right, you have priorities handed down to the Plastic Pollution Action Team from the Bay program leadership. And we're gonna focus on this one because that is what the microplastic monitoring strategy is tied to. Just to give you an idea of what the leadership said, hey, this is what you guys have to do once you create this action team. And this is kind of the outline of the document. We go into the goals and priorities of the PPAT. This is different from the charges that the Chesapeake Bay leadership provided the PPAT. These goals and priorities were born out of several conversations within the PPAT themselves, and they're like, hey, this is what we got to focus on with the monitoring strategy. Tetra Tech took a lot of time to inventory the existing monitoring programs that happen all throughout the watershed. I'm talking about like at a large scale level, Bay scale level, state, county, and where we could more like non-government organizational programs in academia. And then within the existing programs, how might they be applied to the questions that we want to answer? So we want spatial distribution at varying scales. We want it at county level. We want it at state level, just so we can have more information, be able to build trends and answer more questions. Concentrations and trends. Find the hotspots. Where are these microplastics coming from? What sources are they coming from? What are they made of? Exposure pathways. Is it coming from stormwater? Is it wastewater? Is there a hotspot near agricultural land? We got to find this out. And then concentrations and toxicity. The Bay program is focused on ecological and human health. So how are these microplastics affecting ecological health on a population level? What risk does this pose to people eating fish and crabs from the Bay, recreational fishing? Like, what information do we need to provide to them in terms of health? And then we developed monitoring framework recommendations. This is a set of 10 recommendations Tetra Tech put together for the PPAT as a result of this monitoring strategy about how to use it and like maybe research goals we should be thinking about. And then this is the part I was most a part of, the field sampling and laboratory reference guides. So if you want to implement a monitoring program at your organization, these are the questions you need to think about. This is the equipment you think you might want to be using. It goes into a lot of detail about that, so I won't go into a lot of detail there, but they're very interesting to read. Okay, setting goals and priorities. These are the goals I was talking about that are different from the leadership goals. This is from the PPAT itself. So we need a current status. We don't have a baseline of what's going on. And from that baseline, we want to be able to predict future trends of what we might see depending on different tidal patterns and seasonal patterns, just so we can anticipate and better make management decisions. So there's not a lot of information. This is a good place to start. We need spatial distribution. What are the exposure pathways? Like I was saying before, is it coming from the air? Is it coming from wastewater? What are the sources of the plastic? Where through spectroscopy, we're able to identify what polymers are being used, and we can kind of backtrack that to maybe hotspots of what are macroplastic or original piece of plastic that was used to create that microplastic came from. Just kind of like microplastic forensics is the best way I can put it. Concentrations of plastic pollution in the food web. Like I said, there was a human health concern in addition to the ecological health. Discernible impacts evident from plastic pollution on the watershed, living resources, and human well-being. What are the behavioral changes we're seeing at a population level within the fish? Like, is it affecting the way they migrate? Is it affecting where they go get their food, et cetera? We need to be able to answer some of those questions so we can think about the fisheries management impacts. And then the management response. We need to know that whatever action we take is we can measure what's happening with that, whether it be increases or decreases, but we need to be able to get feedback on that so we can make further decisions. And then here's a little bit about the field and laboratory appendices, the guide appendices on there. They're separate. I'm going to talk about the field one a little bit first. It goes into monitoring different media like sediment, water surface, water column, and living resources. So not all of this is done, not all of microplastic monitoring is done via water. We give information on how to monitor different media, what equipment to use, frequency, scale, and all of this information is going to depend on what research questions you have and what your goals are and what resource constraints you have within your organization. So it really kind of gives you an idea of how to think about setting up the monitoring program that you want to incorporate. And then there's a little bit more information. I'm less savvy on the laboratory methodologies one, but it includes extraction techniques like using hypersaline water to pull the microplastics from your samples, how to isolate, identify, package them for further analysis, and then different kinds of polymer analysis to use. Okay, and just to set the stage, I'm sure you are all familiar, but in case you're not, this is the Chesapeake Bay watershed. It covers parts of 7 jurisdictions and states, including the District of Columbia. It's 64,000 square miles, so you can imagine that there are a ton of microplastic sources and details and information that we can glean from this area. And then we go into how to integrate this monitoring framework within existing monitoring programs at the Chesapeake Bay. So we kind of break it down by 4 scales. The largest scale is going to be Chesapeake Bay wide monitoring. So you can see that the Bay program has a river input monitoring program that is monitored really frequently, and it's basically what's coming in from the rivers to the Bay. This would be a good spot to check if we are making management decisions on land, how are these helping reductions in microplastics coming into the Bay? It's a good place to start. Monitoring already exists there, could probably be used for microplastics. Another one that is Chesapeake Bay wide is the non-tidal monitoring network. There are 123 active stations sampled across all states and jurisdictions in the watershed. They are monitored way more regularly than I'm aware of that RIM is. So you can get inputs from on the land about what's going on. Tell them the story. Where are we seeing hotspots of microplastics? Again, would theoretically not be the hardest thing to add microplastics to. And then as far as I'm concerned, every state does have a surface water sampling program. So ideally, we want to get like a little bit more finer scaled information to help more localized issues. We can do that with statewide and regional monitoring. This is just to show the waitable locations in Virginia where they may be monitored and how widespread it is. It'd be good to get information that we can recognize trends with. And there are local monitoring programs as well, like counties and even cities. I know Baltimore has a monitoring program, but Prince George's County, we've actually worked with them for the last 30 years on their surface water monitoring program. In the last 12, they added a trash monitoring program, and in the last 1 year, have added a microplastics sampling program that we actually were able to develop based on information that we developed in the monitoring strategy, and it was really, really fun to pilot that, and it was awesome, and it's just like, okay, we can do this, like we can add this to different programs, but they were really on board with it, and it went pretty smoothly. There's definitely like points where we learned some good lessons, but it's gonna be different for every program and their needs. Okay, and then more existing monitoring programs, even smaller than the local governments. We've got non-government organization monitoring. So this shows the Patapsco Heritage Greenway. The Patapsco River is to the west of Baltimore, and this is a volunteer-based program. I would say the hardest part of adding microplastic monitoring to smaller organizations like this would just be capacity and like resource concerns, because it's not cheap, but it could happen. Okay, I'm gonna come to this slide, sorry. Give me 1 second. Okay, so not all not all microplastic monitoring has to be done in water. As you can see here, we've got sediment monitoring and zooplankton water column monitoring. Possibilities that we could add this strategy into. So the reason we include this is because it's kind of analogous to nutrient reduction monitoring that started in the 80s. Again, this is all super bay focused. Like I was saying earlier, we want to see what the final inputs into the bay are. So we're kind of hoping to treat it like this. So the further spread we can get between water, sediment, and living resources, the better idea we're going to have about the way microplastics are affecting the bay and the critters that live there. And then this is just 2 examples of programs that exist at different scales and can provide very good data. Like I was saying before, spatial distribution is super important in telling the story of what microplastics is doing to the watershed as a whole. And then this is a wordy slide. I didn't really change it because I wanted to keep this in here in case anyone really wanted to read it. We wanted to acknowledge that it's not always practical to monitor for microplastics at all locations within a program, but focusing on the type of microplastics found, for example, the shape, material type, can help link the pollution to different sources. I know I already touched on that a little bit, but like if you were thinking of resource constraints within your program, this might be a good way to go about it, and it just kind of makes more sense in general. Monitoring near potential sources like landfills or wastewater treatment plants can provide more information and is likely the easiest way to reduce local pollution in the future. If you want to get straight to the point, go to where you think it's coming from to begin with, confirm that, and then go from there. But yeah, it's a good example of what can be done based on your research goal and research constraints and just available resources. And then monitoring for concentrations in toxicity of microplastics in ecological health and human health endpoints. Like I was saying before, this slide is kind of the link between the ecological risk assessment that Tetra Tech did with the juvenile striped bass for the plastic pollution action team. So just kind of get to the questions like, how are the fish and crabs ingesting microplastics? From where in the food web are they coming from? How much? And how is this affecting them on a population level? You can kind of see in that map over there, the Chesapeake Bay is currently divided into 9 different segments, and the color of this map shows the fishery sampling locations within each of the segments. The higher numbers being the pink colors, so there are a ton of opportunities for living resource monitoring as well. VIMS already collects the biological data on fish populations, including stomach content analyses, and it could just help us gather better ingestion data in the future. And then these are the recommendations that Tetra Tech provided to the PPAT based on the development of this monitoring strategy. I'm not going to go through every single one of them, but I'll show you because I'm a little bit short on time. But again, they highlight a lot of like what has already been said. And then I will say to the last point, undertake scientific studies on the degradation of plastics and the roles of vector of toxicity. I know PFAS and Vibrio like attaching themselves to plastic, so that could be a potential problem too. So that's what we left the PPAT with. And you think that might be done. I mean, the end of this presentation, but it's not. So I want to talk a little bit about how we are able to already apply this monitoring strategy framework in real life to help reach the goals that we just talked about. So the first thing we did, Bob could better tell you this. I don't know how exactly this came about, but EPA has Region 3 had a vested interest in the PPAT and how the microplastic research kind of developed in this area. So they had money, not a whole lot, to give us to do a source tracking study in the Potomac River. So we identified 18 sites in watersheds dominated by land uses and land types like agriculture, urban, wetland dominated. And then we also considered wastewater and stormwater as its own separate land types. So we went around to these 18 sites and we sampled each of them twice, once at base flow conditions and once at storm flow conditions to see kind of what we were working with. And it was really fun. And it was relatively easy, but the base flow conditions showed higher concentrations of plastic than the storm flow conditions did. And there was no significance between the concentration of microplastics we found and land use type, which I thought was very interesting. Something to consider. And then we also, this happened this summer. I touched about this a little bit earlier, but Prince George's County in Maryland ran a microplastics study, pilot study at 20 different sites throughout the county this year. We set up the monitoring program using the strategy framework, and we helped do some of the sampling. As you can see, we toted that net around to 20 stream sites throughout the county and let the water flow into it for 20 minutes, collected the cod end, rinsed it out, and then sent the sample to our lab to separate it. And then we sent the samples to a lab we're working with at Catholic University to do the polymer analysis. So we don't have that capacity in lab, but it was really interesting. Again, more lessons learned. And we don't have those results yet, but we're really looking forward to them. And then if you scan this QR code, that will take you to the monitoring strategy that I just spent a lot of time talking about. And then if you have any questions, please email my supervisor, Bob Murphy, or myself. Thank you very much.
Thank you, Paige. I have several brilliant questions, and let's be honest, Katie Morgan wrote them. But in the interest of time, I'm just going to ask one, and then I'll open questions up to the audience. We have mic runners who will be on either side of the room, so just raise your hand. We'll also be, they'll be keeping an eye on the Zoom moderator in the back, because I kind of hope that Katie's listening right now and might have something to say. So Dr. Yan, Paige, my first question for you both is kind of to bring it back to that push-pull between science and policy. How do you see your work or the frameworks that you've helped build kind of guide decision makers as they shape policy responses to microplastics?
I can go first. It's really kind of like can you hear me? It's really kind of like a chicken or the egg type deal, because the problem exists, a little bit of work is done, and then you bring it to decision makers and they're like, well, it's not enough, so we're charging you to do this thing. And it's kind of back and forth until there is a lot of information. But the purpose of the push for more microplastic related science in the Chesapeake Bay watershed is just to develop what they need for the ecological and human health aspects to be able to make decisions. The role of the PPAT is to develop that baseline information and help fill the gaps necessary in making those decisions. Scientific studies like characterizing polymer type, hotspots and likely sources are going to be the most helpful in making decisions, but right now, that's the charge we have, and I'm not sure what decisions are going to be made until the policymakers decide that we have enough information.
Yeah, I agree with you. Can you hear me? No? Oh, yeah, it's okay. Sorry. Okay. So yeah, basically from my understanding is we actually, as researchers, we try providing the scientific evidence for the policymakers. For example, you know that why we have PM 2.5 being regulated by the EPA, because Harvard six city studies showing the the healthy relationship with that. So what we try to do is providing the basically scientific evidence so that we know where it's coming from and how getting in the body, how crossed into the different organs, how affecting our next generations, like our kids, and also how affecting our seniors, for example, that neurodegeneration disease. So what we are really doing is trying to provide scientific evidence for that.
Thank you. Any questions from the audience?
Thank you. To your point there regarding the impacts, human health impacts, are you aware of other studies or planned studies at Columbia on that topic to help decision makers? I think once there is sort of the smoking gun and people say, oh my goodness, this is causing such and such, or certainly correlates, that much more could be done. And I just wondered, are we getting into that frontier now?
So the health study is very, very time consuming, so it takes a lot of time. So for example, you first have to go through the larger numbers of the people, right? For example, right now we could not actually set up the exposure models because we don't really exactly know how much getting into their body, how, is that from the drinks or from the airs, from the, the food. So we tried to do it, but the problem is that right now the NIEHS, we talked with NIEHS directors, and we try to even just set up the exposure model so that we know, where the major source from. And however, there are reviewers thinking this is not scientific important. They are thinking this is not novel. So we have difficulty to get even money for the exposure studies. So that's why we are actually talking with the private foundation to see whether we can set up. Of course, there was many others. Currently, there was quite a lot of new researchers to try to figure it out. For example, we know the University of New Mexico. They recently have a study showing whatever the microparticles in the brain tissues, and also we are also collaborating with the Europe groups to figure out a neurodegeneration disease on that. So I know there was a couple of the studies on. We just recently got a big R01 from the NIEHS, National Institute of Health, to basically examine the micro nanoparticle in the tissues, more than 500 people, and then we try to get enough of the sample size so that we can get the statistical analysis being done. So this is still ongoing. I would say probably within the next 5 to 10 years, the landscape will be very different.
Dr. Yan, I was really interested to hear about the work with the UN and those 8 roadblock countries. I was wondering if you could share a little bit more about the strategy for communicating the importance of reducing plastics in the environment with them, and also you had mentioned, I think, maybe Kazakhstan. If you could share a little bit more.
Yes, thanks. So that this is kind of interesting. So that my students, I'm teaching course in the Sustainable Science program. So I have a student from the Kazakhstan, and she's from the Department of Energy. So she was in the negotiation table in the ICAN 5.0 in the Beizhan and also in the Geneva. So basically, she's in the table. So that I would try to contact. I was looking when I talked with her. I said, "Well, I know your countries rely on the GDP." GDP on those, plastic productions. However, this is, your countries also get a lot of pressure from the other countries, like the coastal areas countries. So they really want to get this pass of the negotiation table in the treaty. So I will talk with her, and they say, how can we help you as a Columbia Sustainable Science program? So we are setting up this capstone project in the next spring. So we're going to inviting their countries and get their data and then try looking for what's actually the method, the best method for them. Not only can remove the plastic waste, but also maintain their GDP. So this is kind of ongoing, like negotiations. And also, that the great things of the Colombia is we are at New York City. And New York City is, the United Nations is in the headquarters in there. So we want to use that as a model and then talking with other countries like Saudi Arabia and Iran and also the other countries to see, okay, so we have found this solution for you. For this country, could you also collaborate with us for the continuation? So this is kind of things we are strategies starting from the countries we know we can collaborate with and then putting up some of the practical solutions for them and then reaching to the other countries to solve the sticking points for that.
Hi, Christy Liskey from Delaware, Dunrick. This question is for Dr. Yan. You talked about the laundry filtration system that you are designing and engineering. How far away, like many years, months, are you out from that being something that's commercially viable for an everyday consumer? And also, do you have a communications plan for communicating the benefit of using one of these systems?
So that's basically two questions. One is that how far away. So currently we have patent being applied, and also we have the prototype already. So currently the options is for the laundromat because this is over capacity. So that's the things we actually being ready. So that's why the Mobi groups is the company is actually trying to commercialize it quickly. So probably in the next several months we should have the instruments are being ready for that like a laundromat and also hospital, etc. But for commercial, for the personal usage, like household ones, we need to miniaturize that because that's too big right now. We want to miniaturize. But the great thing is we already prototype, we know their work so that we can really have the room to miniaturize and then put it inside of the washing machine rather than extended, device. So that's kind of probably like 1 to 2 years away from the marketing. So that's kind of things, yeah. So your second question is how we getting the communications. And so currently that's why we are working together with nonprofit organizations. For example, we're working with Judy Ernick from the, Beyond Plastics, and then to look into how we can, at least to starting of New York to pass this, regulations for the microfibers. And so we're also working with other, communications, other, nonprofit organizations, and also working, try to have a webinar after we got all the results, and then inviting everyone come to this conference to introduce our research, and working together with these nonprofit organizations. Yeah.
Fantastic, and I think we are at time, so I encourage you all to use the time during lunch. We've built in some extra time for networking to ask any extra questions.